Today we're going to look at distributive property and how we can show 3 plus 1 times 5 plus 1 using this image below. Here we have a 3 by 5 rectangle surrounded by a 5 by 1 rectangle, a 3 by 1 rectangle, and a 1 by 1 square. The first thing we need to do is to distribute 3 plus 1 to 5 plus 1. I'll show you how to do that here. My first step is to mark where I'm distributing each number. I need to make sure that I distribute my 3 to each term in my second set of parentheses, and I need to distribute the 1 to each term in my second set of parentheses. What that means is I'm going to multiply 3 by 5 and 3 by 1. I'm also going to multiply 1 by 5 and 1 by 1. Now you'll note that I'm adding these terms together, so each set of parentheses gets added. Now we will look at how that relates to the illustration. From before, I had 3 by 5, 3 by 1, 1 by 5, and 1 by 1. Those are the terms I got when I distributed each term in my first set of parentheses to my second set of parentheses. I'm going to look at my shapes here and see where I can start making connections. I see that this rectangle is 5 units wide and it is 3 units tall. It is 3 by 5. I see that this rectangle is 3 units tall and 1 unit wide. It is 3 by 1. This rectangle is 5 units wide and 1 unit tall. It is 5 by 1. And my little square here is 1 by 1. So when I distributed my terms from my first set of parentheses to my second set of parentheses, I found my 3 by 5 rectangle, which is my original dimensions. Then I found 3 rectangles that I had to add on to it. I can see 1 by 5, 3 by 1, and 1 by 1. That's these terms here. Now let's look at how distributive property might work if I were subtracting. Previously, I found that when I was adding the terms in the parentheses, I would add on rectangles to the height and to the width. If I'm adding on to my area when I'm adding in the parentheses, I should consider taking away from the area if I'm subtracting in the parentheses. So I have a rectangle that is 3 units tall and 5 units wide. I chose 3 and 5 because those two terms make a rectangle I can draw. It's hard to imagine a rectangle that is -1 by -1. So taking my rectangle that is 3 units high, I now need to imagine it as 3 minus 1 units high. So I could take away a unit from the height. I am now left with a rectangle that is 2 units high by 5 units long. My second term shows that I have 5 minus 1 for my width. So I'm going to go my 5 units across and remove 1 unit from the width. 5 minus 1 is equal to 4. So I have got 4 units here and 2 units here. If I were to distribute that out, I would take and distribute 3 to the 5, and 3 to the negative 1, and then negative 1 to the 5, and negative 1 to the negative 1. So I would end up having 3 times 5, that's my original rectangle, 3 times negative 1, that would be this rectangle here. I would have negative 1 times 5, that's this strip right here, and then I would have negative 1 times negative 1, and that is this piece right here. If we were to solve this problem without using the distributive property, we would do 3 minus 1, which is 2, times 5 minus 1, which is 4. That gets us 8. You can see that is the case because we have 8 rectangles, down here. 8 units in our rectangle. When we look over here and we do our distribution, we have 3 times 5 is 15. That was our original rectangle. 3 times negative 1 is negative 3. And negative 1 times 5 is negative 5. Negative 1 times negative 1, which gets us a positive 1, which does some kind of funny things here. So let's start solving this out. We have got 15 minus 3, which is 12, minus 5, which will get us to 7. And then we have a positive 1 back here, which will get us to our answer of 8.